Hey, Algebra, I'm not here today, but I'm here to talk to you about what's a function anyway. And we've been talking about like daily functions, so you're already familiar with them a little bit, but they start as relations, which you already know. You know, a relation is a pair. In fact, that's your first blank. A relation is a pair of inputs with outputs. The input being the x, the output being the y. Again, something that I think you already kind of knew, but here they kind of give an example of the hours you work versus the pay you receive. I mean, if you work 2 hours and you get paid $10 an hour, the input is 2, the output is going to be 20, right? And the function that would be like 10x, you know, y equals 10x, that kind of thing, okay? So vending machines, this is like my number one way to kind of describe functions, is that, for example, if you want to buy this bag of popcorn, then you know that you input a very specific thing. You input, well, first money, but then you also input the buttons A and 1. And if all of a sudden this starts to move, you're going, what's wrong with this machine? You might even, you know, if you're kind of weird enough like me, you'd be like, it's not functioning correctly, not functioning. Because you clearly hit A1 and yet A2 is what's popping out, right? So that is an example of if it's not functioning, because it has exactly one input and exactly one output when it is a function. In fact, that's the last blank before it says determining whether relations are functions. So on that one, when it says determine whether each relation is a function, how exactly could you do that? Well, you could plot all of the points that you happen to have. So for example, this one right here that's on the screen, if we were to plot these points and then ask, is it functioning? Well, the idea is when we input a 1, it outputs 3. So it would look like this. There's that coordinate, 1, 3. When we input 3 right here, it outputs 2 right here. So 3, 2. But hang on a second. Also, when you input 3, because according to right here is 3, right? We've got a problem, because when we input 3 again, we get 5. So this is all of a sudden not a function, okay? Because it's like going to the vending machine and hitting, you know, the right combination to get popcorn, and out pops popcorn. But then also you put in the combination for popcorn up here, and you got chips or something like that, yeah? This is the one where it's not functioning, right? And it's because of that repeated output. So a function has exactly one input with one output, and then it's not functioning. Not a function with one input and different outputs. So let's look at these and kind of determine if they are functions or not. So let's see, we input -2, we output 2. So far, so good. And now really what I'm gonna do is just go and check, do I have any more -2s as an input? No. Okay, I'm good. And that's really all I'm gonna do is just check, okay, can I, you know, there's a -1. I don't have any other -1s, so I'm good. Here's a 0. Don't have any other inputs that are 0, so I'm good. Here's an input that's 1, no repeated ones. Here's an input that's 2, I'm good. And if you're like, okay, well, hang on, you just did the thing with a graph. What would that look like with this one? Well, it would look like this. So that first one was -2, 2. The next one was -1, 2. And you might think, aha, well, there's a repeated input. You said we can't have repeated inputs. Nope, the output was repeated, okay? And what that might seem like is there's like popcorn, and then there's another bag of popcorn, right? Like this is the A1 button and this is like the A2 button. It's okay to have two different outcomes that are the same as long as we have two different incomes for those, or inputs for those. Let's see the next one, 0, 2. Okay, I think you're noticing a pattern here that those first three, that one, and that one, all have the same output, but different inputs, okay? And then let's look at that next one, 1, 0, and x is 1, y is 0, all right there. And then the next one is x is 2, y is 0. So this is a function, yes. And it's because we have unique inputs and outputs. And again, if you're like, but how is that unique? We just happen to have 3 different types of popcorn with these guys. And then let's say that this is A4 and that's chips. And then there was A5 and that's chips. As long as you hit the right button, you get the right output, you're happy. That thing is working. It doesn't matter that there's 2 different kinds of chips, so to speak. All right, and if you're like a little confused, then let's do it again. Let's do the next one. And what I'm gonna focus on is the inputs. Okay, I have a 4 here. I notice there's another 4. Right away, this is not a function. Why not? Because here I hit the combination to get popcorn, and I got popcorn. So actually, here, I'm okay with that. But over here, I typed in popcorn, and I got chips. What the heck? I should have gotten chips. Or I'm sorry, I should have gotten popcorn. That makes it fail. Now, I'll go ahead and graph that just because I think that's helpful at this stage in time. So let's see, 4, 0, 1, 2, 3, 4, 0, 8, 7, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, right there. Let's see, 6, 4, there's 4, 5, 6, 1, 2, 3, 4, 4, 3, 1, 2, 3, 4, 1, 2, 3, and then 5, 2, different color, 1, 2, 3, 4, 5, 2. So check it out. This is where there was that repeated input, okay? And we said, no, repeated input means this machine is not functioning. All right, check this one out. Input, 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 input. Uh-oh. We have repeated input with different outputs. So let's check out what that would look like. Here's the graph. -2, -1, 0, 1, and 2. They go as far up as 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, -2, 3, -1, 4, 0, 5, and 0, 6, 1, 7. Maybe I've gotten kind of off on my graph, but here's kind of what happened. It's like it was going a straight line and then it duplicated, you know. There's where we failed this being a function, okay? All right, one more. And by the way, these are different ways that you can communicate some of this stuff. Obviously, these are points or coordinates right here. This is a table, and this one is called a mapping. This one right here is a mapping. Okay, so let's check out the mapping. This is like hitting the 1 button, and it produces a 4. So popcorn, popcorn, right? The next one, we hit the 3 button, and it produces a 15. Okay, sounds good. We hit the 11 button, and it also produces a 15. This is a function. We are happy about this because, yes, we hit popcorn 1, and we got popcorn 1. And then we hit popcorn 2, but we still got popcorn 1. And you might think, well, okay, now I'm a little confused because we got the same thing. I thought you said repeating was bad. Repeating is bad when you hit the same input and get different outputs, okay? So that would, if I were to do a mapping like that, here's the in and out on a non-functioning thing. If you were to hit 0 and it maps over to 1, but then you hit 0 again and it maps over to 2. This is the one where we're like, no, it's not working, because I hit the same button twice and got 2 different things. This is the scenario where it's like, yeah, there was a popcorn button here and a popcorn button here. That was okay. All right. So now let's take a second and, if you can, pause the video, people, and take a look at these, see what you came up with, is if they are functions or not, and then, try to do your best to explain, in your own words, what you think, okay? So I'm going to pause this, and then I'm going to work them out. Ready, you pause, everyone pause, go. Okay, I'm unpausing now. So I'm looking at number 1, and I'm just looking for repeated input. -5, we're good. 0, we're good. 5 and 5, that's not good, because 5 gave me 0 and 5 gives me 10. No, because of repeated input without unique output. Okay. Number 2. -4, I'm good. -1, I'm good. 2, good. 5, good. We're good. This is a function because we have 1, 2, 3, 4 different buttons, and they all produce something else. And even if they all produce the same thing, it would just be like a flat line. It'd be like having a Coke machine with 4 different Coke buttons. As long as Coke popped out every time you hit a Coke button, you'd be happy about that, right? Okay. Input, output, this is perfect. This is very clearly a function because that maps to that, that maps to that, that maps to that. There is no mapping where there's repeated. So like, let me break this machine with 1 arrow. Boom, that purple arrow breaks this machine, okay? It would not be functioning with that purple arrow. So right now, we're happy. Oh, this one, okay. We have hit the Coke button of just hitting 1/2. And then, okay, look, it popped out a Coke. We're happy about that. But now it's a Sprite, and we did not order Sprite. We hit the Coke button. Oh, and now it's root beer. And we did not hit root beer. We hit the Coke button, okay? So this one is no, not a function. If you're kind of feeling it, kind of think to yourself, where are you at on this little spectrum here? If you're like, no, I don't get it, I can do it, might need a little help, I can do it on my own, or you know what, I'm so good, I can tell somebody else about it. Wherever you're at, let me know what you think kind of mentally. Let's slide over here. I know there's kind of a lot of examples, but now this is going to be your favorite, your best friend, the vertical line test. The vertical line test is literally like this. I'm going to draw a vertical line on the screen. Okay. Let's go with red. Oh, no, there's already a red on there. Let's go with purple. Vertical line, okay? What I'm going to do with this vertical line, and I hope you can see this on the video, is I'm going to take it and drag it across my function. And wherever it hits the function, I'm going to like make a beep sound because I think of it as like a scanner. It's like I'm looking and then I see something and I go, hey, there it is. All right, so I'm scanning the function. If I can select it again, I will do that. Okay, ready, set, select. All right, select, come on, there we go. Beep, 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 beep. Okay, it only hit 1 every time. So guess what? This thing is a function, yay. This one over here, however, beep, 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 I'm hitting 2 at all times, except for literally right there. So the fact that I'm hitting it at 2 places, here and here, says this is not a function. And so this is what that table would look like. It would be like 3, 4, and 3, 1. This is hitting the Coke button and getting Coke, and you might be happy with that. This is hitting Coke and getting Sprite, and we are now no longer happy with our machine. It is not functioning. So vertical line test is your buddy. Okay. Determine whether these guys are functions. Well, I mean, we can pretty much instantly tell this guy fails because he has 2 vertical points like that. So this one's a no. This one, take your vertical line and try and drag it across. Come on. Yep, there we go. Oh, no. Anyway, you get the idea. You dragging a vertical line across that. This one is, oh gosh, come on. This one, yes, that's a function. So here's another moment. Pause the video, reflect, see what you think, which one of these are functions or not. And I'm back. Okay, this one, not a function. Because check it out, vertical line, it fails it 3 different times. This one, yes. Vertical lines each time, just fine. It's just hitting 1 each. And by the way, you don't have to draw 3 different vertical lines. You're not really drawing a line at all. You're just like pretending you're scanning it with a vertical line. So here, in fact, I'll draw the vertical line again. Why not? There it is. Okay, scanning, beep, 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 beep. Only hits 1 every time. Here, I'm hitting 1, 1, 1. It's just hitting 1 every time. So here, we can go back and say, yes, this was a function. Yes, this is a function. I think you're about to find out that this one, not a function, because it hits it in 2, oops, it hits it in 2 spots in lots of places, right? And then the last but not least is this one. This is a function because it only hits ever in 1 place. So here's some more information that you pretty much know, I think, at this point, and maybe you do, maybe you don't. I don't know how confident you are with it, but the domain is all possible input values, and all of our possible input values are x. And then the range is all of the possible output values, that's our y. In fact, they have this little machine here that they say, hey, listen, if we were to input a -2, that's our x, so it would go right there, and we would end up getting y equals 3 times -2, and it would output -6. But what are the possible input values of that machine? Well, if it was a real machine, I guess there's like real answers to that, but this is a fake machine. So the domain for this machine, I'll do it in purple since that was kind of my thing for domain, is really all real numbers. And the same thing for the range, it would be all real numbers. It would be infinite, right? It's infinite, okay? So now we are finding the domain and range of this graph. And all you're really gonna do is just go, okay, x there is -3. So here's what I'm gonna do. I'm gonna write domain, and then I'm gonna write this little brace looking symbol right here. It's just me kind of saying, hey, I'm opening up like a set. In fact, if I were to make that brace a little bit more carefully, it would kind of look like that. Okay, in fact, that was so nice, I'll save it for the range. So my domain is this guy here at -3, okay? That one at -3, and then it happens again at -1, and here at 1, and here at 3. And I'll close my braces. That's my domain. And then here, just to make it the same color. Now my range, here at -2, here at 0, here at 2, and here at 4. So take a second and kind of think on that. Does that make sense? That my domain is the x values, my range is each of those y values. Let's slide over here to look at this one. This one, I can't just write individual things for the domain because there's one clearly at -2, but if I were to zoom in a whole lot, I mean, there's one right there and there and then, right? So here's what we're going to do with that. It's happening. I can write this a couple different ways. So I'm going to write D domain. I can write it like this. -2 to 3, like that, using my less than or equal to, less than or equal to. So if you were to read this, all of the x values that are possible, is -2 possible? Yes. Is 0 possible? Yes. 2? Yep. 3? Yep. How about 4? No. Right? It needs to be less than or equal to 3. So what we call this like inequality notation. In fact, that word notation, that should stick out to you a little bit because we've said that we have things in function notation. It's almost like the word notation used to mean like, this is how we write it. Okay, it's the kind of writing that we're doing. So function notation was like this, right? Inequality notation is like this. And then there's another one called interval notation. And it's going to look like this. So for this domain, our interval would be -2 to 3, like that, where these brackets are communicating that it's the equal to part. And if I happen to have like parentheses, like let's say 2 to, actually let's go 2 to infinity. Like this would be saying less than. And this one, I mean, oh, sorry. The parenthesis is saying less than. And then the fact that we can never actually count up to infinity, you're going to definitely use a parenthesis with that. And it would also technically be like a less than, meaning there's no equal to like there is there. And so let's do the same thing. Let's do our inequality notation and interval notation for the range. So here's the range. It's going to be y is in between. So it's down here at -1. And it goes up as far as +2. So that would look like this, -1, 2, like that. So by the way, here's, the McMath version of that information. Here is like the how a book would communicate it version. So if you want, pause the video, reflect on this for just a second. In fact, I'll mentally pause for you. Okay, let's slide over here. Find the domain and range of the function represented by the graph. Our domain is, we got, let's see, -2, -1. Oh, by the way, this is what you're supposed to be doing. So here, pause for a moment, see if you can't find these, and then I'll unpause and give you the answers. And unpause, here we go. So, -2, -1, 1, that was the 1 right there, and then 2, that is the domain. And here comes our range, is going to be, let's see, +4 and +4. These two, the range part repeats, and that's okay. And then these are both at 2. So check this out. Right here, notice with my range, it only has 2 items. Well, that's because we had this going on. We had -2 went to 4. We had -1 went to 2. We had 1 also went to 4. And we had 2 went to 2. So we did not repeat. These guys didn't repeat, so we're okay with that, right? It just so happens that this function has 2 buttons that both give us Coke. 2 buttons that both give us 4, and that's okay. Also, it's the vertical line test. Like, we know this is a function. I'm just, again, trying to get this point across to you. This guy right here, the domain is, let's see, I'll write it a couple different ways. We got inequality notation. He goes from -1 to 1, 2, 3, 4, 5 to 5. You could write it like this, -1 to 5. And then the range is going to be, let's see, it starts, no, it doesn't actually start. Sorry. One thing that maybe would be helpful, maybe you have picked up on it already, is when we talk about the domain, we start here and we go this direction. But with the range, we start down here and we actually go up. So you probably saw when I did this one that I actually started with 4 and wrote it on the right. And that might have been actually a little tricky for you because you're like, wait, what just happened? Why did he do that? It's because you want to go from smallest to greatest, and smallest is down here, greatest is up here. Same thing with x. Smallest is over here, greatest is over here. Okay. So back to the range. Our range begins with this one at -1 right here. And it goes all the way up to the 3 right there. Another way we could write it is with interval notation like that. Okay. 16. Now wait, is this a function? Yes, it is, because the one we saw earlier that was not a function was like this, and on the vertical line test it fails there and there, right? So, yes, this is a function. Its domain is going to be between x and x. It's going to start at the least at 1 and go all the way over to 5. We can write that like this, and the range is going to start here at 0 and go up to 4. So between 0 and 4, ooh, that's an ugly looking 4. 4 like that. So I'm going to stop the video right now because I think you probably have run out of class time. If you somehow have not run out of class time, well then take a look at the 3.1 worksheet that I gave you. See what you can answer on it today. It's not due today. It's not homework. We'll talk about it tomorrow. Let me know what questions you have tomorrow. See ya.